Good day. This is Group 5 System Analysis Midterm. The objectives for this midterm are evolutionary prototyping during system development, advantages and limitations of each type of prototyping, rapid application development process to create a product. 1. Evolutionary prototyping during system development.
What is evolutionary prototyping? Evolutionary prototyping is a software development process in which a prototype is built initially by the developer. Following the customer's initial feedback, several prototypes are created, each with incremental modifications until the final product emerges. As a result, the prototype evolves towards the final system at each iteration. That's because creating a prototype from start for each process interaction can be time-consuming and tedious.
This is a diagram of evolutionary prototyping.
Example of evolutionary prototyping. An example, developing the user input screen in a purchase order record system. 1. Working with the analyst, the developer quickly puts together an initial prototype of the user input screen. This prototype is then tried out by users who provide immediate feedback. Users try out the prototype and inform the analyst of any changes needed to the interactions. The requirements specification is updated by the analyst and the developer adjusts the interactions as needed. The user tries out the adjusted prototype. They can either accept how it is now working, or they once again inform the analyst of any changes that should be made. There, the process repeats. 5. The interaction aspect of the interface is eventually accepted and signed off. 6. Now the developers begin work on the graphics and the way the input screen actually looks. 7. A new prototype is released, now with all the graphics set up properly. The user tries out the prototype and comments on the design. Any changes needed are added to the requirements specification and the developer carries out the change. 8. The prototype evolves towards the finished system.
2. Advantages and limitations of each type of prototyping. Rapid throwaway prototyping. Rapid or throwaway prototyping is the quickest and most cost-effective prototype process. This prototype was made in a short amount of time and does not have any real-world functionality, focusing solely on design. Advantages. It's a quick and easy approach to view the project and discuss its details. 2. Making a dummy model is inexpensive. Limitations. The end result is simply a proof of concept to gauge interest. 2. Prototypes are frequently discarded and cannot be employed in the development process. Evolutionary prototyping. Evolutionary prototype is a type of prototype that progresses from a basic framework of a software's product structure to something more complex and functional. Advantages. The product improves as a result of customer input. 2. Without wasting time or throwaway prototype effort, the prototype becomes a functional product. Limitations. 1. It takes a little longer than other methods. 2. It is more expensive than other procedures. Incremental prototyping. The incremental method to prototyping appears to be more of a horizontal process, with increasingly complicated features being added on top of the core ones over time. The project is divided into minor components and developed independently by the developers. Each element is developed and tested separately before being integrated with other features at the end of the development process. Advantages. The product can be faster because multiple teams of coders can work on different features at the same time. 2. Without waste or duplication of effort, the prototype becomes a product. Limitations. Some design elements may not fit well together during the integration stage. 2. If certain components are well done but others are defective or underperform, the end product's functionality may be poor. Extreme prototyping. This approach is frequent in web application development projects. The app architecture, which often comprises of presentation and service levels, is used to create the extreme prototype. Advantages. All aspects of app development are taken into account. 2. The strategy combines back-end and front-end development in a seamless manner. 3. Clients can get a working app immediately because the time to market is short. Limitations. 1. The emphasis is on the coding rather than design. 2. It's not suited for outsourcing because effective project outcomes require the client to meet with the development team in person. 3. Many changes occur during the development process which might be difficult to track. 3. Rapid application development process to create a product.
What is rapid application development? Rapid application development is a software development process that prioritizes rapid prototyping over extensive planning. A prototype is a working model that functions in the same way as a product component. RAD model design. RAD model distributes the analysis, design, build, and test phases into a series of short, iterative development cycles. Following are the phases of the RAD model: business modeling, data modeling, process modeling, application generation, testing, and turnover.
RAD model design, business modeling. The information flow and distribution between multiple business channels are integrated into the business model for the product under development. A comprehensive business analysis is conducted to determine where critical business information can be found, how it may be obtained, how and when the information is processed, and what elements drive success information flow. Data modeling. The information obtained during the business modeling phase is evaluated and analyzed to create collections of data items that are critical to the company's success. All data sets attributes are identified and defined. In regard to the business model, the relationship between these data elements is formed and defined in detail. Process modeling. The data object sets created in the data modeling phase are converted to provide the business information flow required to meet the business model unique objectives. This phase defines the process model for updates or enhancements to the data object sets. There are descriptions of the process for adding, removing, retrieving, and altering a data object. Application generation. Application generation is using automation technologies to translate process and data models into actual prototypes. This step is where the actual system is designed and coded. Testing and turnover. The RAD model reduces total testing time because prototypes are independently tested during each iteration. The data flow and interfaces between all of the components, on the other hand, must be adequately validated with 100% test coverage. The chance of serious issues is reduced because most of the programming components have previously been tested. This is a diagram of the RAD model design. Thank you for watching our presentation. Next is the work cited.